All right, so you have this paper called Dilations from a Point. It has name, date, and period. This, normally when we have name, date, and period, you would turn in this and this would be considered an assignment. We're actually gonna consider this notes. I'm gonna do about half the problems. I'm gonna ask that you do half the problems. The problems I'm gonna be working on though are the first set of problems. So number one, A with the pair of A and B, C with the pair of C and D, and so on. When I go over all these problems, when I conclude it, I'm going to ask that you complete the other problems that we do not go over in this video. Okay. Now we have varying questions. For number one, what happens when the center of dilation is a vertex of the shape? So we're going to focus on one of these two shapes here. It's going to be the gray one. As you can see, for A, it says dilate triangle ABC from C using a scale factor of 2. We're going to highlight two things here. This is going to be our center of dilation, and 2 is going to be our scale factor. And I'm also going to highlight that here as well. Okay. So we're going to find the path that it takes from C to get to A, to get to B, and to get to C, and then multiply it by 2. I'm going to start with A. So the path from C to A, I'm going to draw this, but you don't have to draw this. The path is 1 left, 3 up. Okay. So I'm going to draw that here. 1 left, 3 up. Since our scale factor is 2, that means I'm going to multiply them both by 2. So instead of 1 left, it's going to be 2 left. 1, 2. And instead of 3 up, I'm going to multiply that by 2. It is 1, 2, 3, 4, 5, 6 up. So that's where it is. I'm going to get rid of these arcs. And this is where A prime should be. Okay. Next one. To get from C to B, I'm going 2 right. And, 2 and 1 up, right? As we go 1, 2 to the right and 1 up. Multiply by 2, it's now no longer 2 to the right, it is 4 to the right and 2 up. So 4 to the right from C, 1, 2, 3, 4, 2 up. It should be right here. This is B prime. And then finally, for C, since I start at C here, you really ask yourself the question, right? How much do I have to move to get to C? You don't have to move at all. We're actually on that point. So when we have a point on the center of dilation, it actually does not move. It stays on that center of dilation. So C prime is still on that same point. We're going to connect A prime, B prime, and C prime to get our triangle. And right there. Okay. So as you can see, we have a triangle within this triangle. I encourage you now to try your problem. At the end, you're going to dilate this triangle here from point D using a scale factor of 3. So a couple different things there. Let's move on to C. We're now going to translate this triangle using point A. And we're still going to keep the same scale factor. Okay. And if I'm going a little bit too fast, right, pause the video. Let's highlight that point here. I'll start with A, right? Since my center of dilation is also coincidentally A, that means I do not move. I'll put a point here. That means A prime will stay there. From here, B, the path from A to B looks like it's 1, 2, 3 to the right, 1 down. So 3 right, 1 down. Let's go like this. Multiply by 2. So instead of 3 right, it's going to be 6 right. 1, 2, 3, 4, 5, 6. And instead of 1 down, multiply by 2, it's 2 down. This is B prime. And finally, to get from A to C, we're going to go 1, 2, 3 down and 1 to the right. So 3 down, 1 right. We'll draw the path here. So multiply it. So for this will be, all right, 6 down, since I multiply that by 2, and 2 to the right, right? 1 times 2 is 2. So 6 down, 2 right. Let me erase this to get out of the way. 6 down, 2 right. 1, 2, 3, 4, 5, 6, 2 to the right. This should be C prime. Okay, let's connect all the points that we have. We talked about this in our guided notes, right? Every image point and pre-image point and the center of dilation are all collinear, meaning, right, notice how B prime, B, and our center of dilation, they're all in the same line. Let's put this in blue, right? C prime, C, and our center of dilation, they're also collinear. So that should always be the case. Now, what we have for the next one, number 2, we're going to go over number 2A. I'll have you do number 2B. But now the question is, what happens when the center of dilation is inside the shape? We have G here. That is our center of dilation, and our scale factor is 3. And I'll highlight that here. I mean, it's still the same thing, right? We don't have a point that's exclusively on the shape. But let's look at every part here. And we're just going to identify the path. So from G to A, looks like we go 1 up, 1 left. So it's right there here. 1 up, 1 left. I'm going to multiply that by 3. So if I multiply that by 3, it's now 3 up and 3 left. Okay. So I start at G. We always start at our center of dilation. So go up 1, 2, 3, 1, 2, 3 to the left. It should be right over here. This is A prime. Next one, B. It looks like B is 1, 2, 3 to the right. So it's only in one direction. So 3 to the right. My scale factor is 3. So instead of 3 to the right, 3 times 3 is 9 to the right. So let's count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm gonna get rid of these arcs. This is B prime. So, right, multiplying by 3, very different than multiplying by 2, where we get a very big object. And now from G to C, that's 1, 2, down. So 2 down, multiply it by 3, it's now 2 times 3, 6. 6 down, 1, 2, 3, 4, 5, 6 right here. This is C prime. All right, once again, we're going to connect all the points. All right, and when we have a dilation inside the shape, we get what are called concentric triangles. A triangle within another triangle. I mean, for these ones, you do technically have a triangle within another triangle, but it's on the boundary and the edges of the triangle. So that's a little bit different, right? We can see subtle differences there. Now, this next part, I don't want you to draw, but I do want you just to focus on this. We said the dilation, or center of dilation, pre-image, and image are all collinear. So notice what we see here. If I connect G to C and C prime, that's all in the same line. Same as GB to B prime and GA to A prime. Those are all on the same line. And you can kind of, I don't know if you can see this, but you can kind of get this pyramid shape. Think about if you're looking at it from the top, like maybe think you're on like a helicopter, we're looking down the Luxor on the strip. You get kind of like this looking figure here. So we use this a lot in architecture, geometry. Let's go to the back side. So 3 more, we're about halfway. All right, so same idea here for C. We're gonna dilate this about point G, but now we no longer have an enlargement, we have a reduction. In this case, since it's 1/2, it means we are dividing by 2. All right, so let's identify the path and then just cut it in half. So the path from G to A is 2 up and 2 left. So 2 up, 2 left. All right, we'll cut that in half. I'll write this above here. So that means A prime. 2 divided by 2 is 1, so it'll be 1 up and 1 left. So from G, 1 up, 1 left is right here. Right, and you can see G, A, and A prime, they're all collinear. They all form a straight line. G to B, this one's a little bit different. We're not going to get a whole number. But let's go right and then down to get to B. So 1, 2, 3, 4, 5, 6, 7, and down 1. So 7 right, down 1. Okay, we got to divide those both by 2. Now, what the issue here is they're both odd. So only when you divide even numbers you get a whole number. But that means B prime Instead of going 7 right, half of 7, right? If you have $7 and you split that, the only way to split that would be $3.50. That's three and a half. And instead of going 1 down, divide that by 2, you're going to go a half down, 0.5. So let's be careful on how we graph this. It's not going to be on a grid mark. It's going to be in one of these squares within the grid. So 3.5 right, 0.5 down. So 3.5 right, 1, 2, 3.5 right there. Not quite to the next box. And then a half down. So it looks like this right here. It should be right there. Okay, let me rewrite this just so we don't have the path kind of in our way. So it's right in the middle of this box. That's a little bit unusual, but it's still collinear. This is B prime. Next one, we have C, which looks like we're just going down. That is 1, 2, 3, 4, 5, 6. So C prime, cut that in half. It's now 3 down. So 1, 2, 3, C prime. Let's connect all these points. Right, we get these lines, these line segments that they're parallel, right, to the original triangle. Right, B to B, A to B. This line right here is parallel to A prime to B prime, right? That is, right, they're never going to intersect. Ooh, whoops. Let's undo that. Okay. And now moving on to number 3, we have 2 parts in number 3, one with an enlargement, one with a reduction. So the question in this case, a little bit different. What happens when the center of dilation is outside of the shape? Right, same exact process. We're looking at the path, but we can see maybe the differences there. So we're gonna do 3A and 3C. For 3A, dilate triangle ABC using G. And a scale factor of 2, we're going to double. All right, A, B, and C. So from G to A, it looks like it's just 2 to the right. So let me multiply that by 2. Instead of 2 to the right, it's 4 to the right. So 1, 2, 3, 4 right here. This is A prime. G to B, there's multiple directions we got to go there. But this is 1, 2, 3 to the right. 1, 2, 3 right, 2 down. Okay, multiply by 2, so this is 6 right, 4 down. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's close to the other triangle, but that is B prime. And finally C, we're going to go down 3. Multiply by 2, we're now going to go 6 down. So down 6, 1, 2, 3, 4, 5, 6. That's C prime. All right, not too bad. We're connecting here. Connecting, whoa. Let's get rid of that. And connecting here. All right, so we get this triangle, should be same shape, same size. I'm gonna draw this in red. You do not have to draw this, but we'll connect. Right, that's collinear. That's collinear with our B's, and this is collinear with our C's. They all lie on the same line. Okay, we'll get rid of that. And last one that we'll do here and explore here, we have a reduction. We're gonna now dilate G using, or dilate triangle ABC using G by a scale factor of a half, meaning we're dividing by 2. Let's start with our path from G to A. A is, so this is 1, 2, 3, 4, 5, 6, 7, 8 to the right, 2 down. 8 right, 2 down. Let's remember that. Okay. So A prime is going to be 4 right, 1 down. 1, 2, 3, 4, 1 down. This is A prime. Now I'm going to connect here G A prime to A. This shows you that A prime is what we call in geometry is the midpoint, right? It's directly in between our center of dilation or our pre-image point if this is a reduction. Anyways, I'm going to get rid of that because that's actually not part of the triangle. B. Long path to get to B, but this is 1, 2, 3, 4, 5, 6, 7, 8 down, 1, 2, 3, 4 right. 8 down, 4 right. Divided by 2, it's going to be 4 down, 2 right. So 1, 2, 3, 4, 2 to the right. It's inside this green triangle. And finally, C. C looks like it's just down 3. So for C prime, we're going to have to divide it by 3. We have another odd number. So this is now down. What's half of 3? It is 1.5, 1.5. This will be down 1.5. Should be right there. Let's get rid of the arcs to connect this. Oh, whoops. Right there. C prime. Right. A prime to C prime, A prime to B prime, B prime to C prime. There we go. All right, so the other parts that we did not complete, I'm going to have you just practice, right, performing reductions and enlargements. You'll keep this still within your notes. It's 3-hole punch, so you're keeping with you to study and use for assignments, practice, and when we prepare for our quizzes and tests. Now, when you're done with this, you'll move on to Map Accelerator, but finish this paper first prior to that. All right.